James is our speaker today. Like I said earlier, James is the head of data and engineering at In Marketing We Trust. So I don't want to steal James's thunder too much, but a bit of background. James is a developer. He was involved in the development of a BI product for a long time and before joining us, and got involved in, I think, James, it's fair to say that we were probably your first brush with the world of SEO. And since then, James has got deep into all things PageRank, and he's helped us build out this solution. Well, not helped us, he has built out this solution. And whenever I say we, when I'm talking about the projects we work on with James, it really is the royal we. I've done nothing on it, but I will claim all his glory. So James, over to you. Do you want to share your screen? Cool, just a reminder. Sorry, James, one last thing. Just a reminder, guys, that if we've got questions, we're going to ask them at the end, okay? So just jot down your questions as we go. And at the end, I will allow, depending on time, probably anywhere between 5 and 15 minutes to ask the questions that you have, okay? So over to you, James.
Cool. I'll take over. Hopefully it works.
Let's give it a go.
If I can click in the right spot. Shit. So is it all good, Paul?
Yeah, you're good.
Awesome. Thank you. So yeah, thank you for everybody for coming to my talk about data-driven internal linking optimization. So I'm happy to see a few familiar faces in the audience, but for those who don't know me, and Paul just introduced me, of course, I'm James. I'm the head of data and engineering at IMWT. I'm based in Melbourne, which most people probably know has a pretty full-on coronavirus lockdown at the moment. So I have a lot of time to sit around by myself thinking about internal linking. My background is as a software engineer. I spent about 10 years working on business intelligence products, and that's how I got my start working with data. And I've been working with IMWT and internal linking projects for about 4 years now. So since I'm a developer, my main interest in working with data is kind of on the tool building side. In my team as well, I have Roberta, who's our technical data analyst, and Maggie, who's a great data scientist. So I think that we have a really well-rounded team that does some pretty cool stuff. I'm a good Melbourne hipster, so I'm pretty into beer. You can see behind me, I'm working from home. Well, you might not be able to see because I'm sharing my screen, but I have my my little home brewery behind me. And just a little story about this, that about 10 weeks ago, I moved into a share office, and then I had to move out a couple of weeks later because of the lockdown. But you know, I was trying to talk to the guys who work there about the work I do, and they're not very technical. So I was trying to explain to them that I work on big sites to help optimize their internal links, and the idea being that internal linking optimization helps with SEO performance. So I sat and gave my spiel about internal linking for about 5 minutes, and after I was done, one of them said to me, "Okay, that sounds really good. What's a link?" And I couldn't figure out how to explain to him what a link was. So just keep that in mind if you have any questions, that my question answering ability doesn't extend to explaining what a link is. So maybe ask me about beer instead. So talking about internal linking, when I talk about optimizing internal links, what I mean is that we're trying to identify the most valuable pages on the site and then link to them in a way that maximizes the number of links to the pages we care about, minimizes the click depth to those important pages, and maximizes the quality of the links to those important pages. And I'll talk about each of those things. So maximizing the number of links is pretty self-explanatory. The idea is that the more links we have to the pages that we care about, the more we're telling Google or other search engines that those are important pages. minimizing click depth is also a fairly easy concept. We want to make sure that the pages that we care about are within as few clicks as possible of the homepage. Again, a strong signal to Google that those are important pages. And we want to send high quality links to the pages that we care about. And this is a little bit more of a nebulous concept. It could mean a lot of things, but for our purposes, it means a link from a page which is itself obviously important to Google, and a link that has content that's relevant to the page that we're linking from. So luckily for us, there's a metric which combines all of those things. So as Paul said, we look at PageRank. So I guess a lot of people here have probably heard of PageRank. PageRank was Google's initial algorithm that they used to rank search results. It's named after Larry Page. And the idea of PageRank is loosely just that if a page is important, it's likely to be linked to by other important pages. So yeah, it was the original brain that powered Google. When we start talking about PageRank, usually there's a couple of questions we get about it. So the first one is, isn't PageRank dead? And the answer to that is no, it's not dead. It's still in use. You can dig up confirmation from Google that it's still used as one of their ranking signals. It's just no longer there to be seen. So the confusion with that comes from the Google toolbar in about 2013 or 2014. It used to show what the page rank for a given page was, and yeah, about 6 years ago, Google removed that. So out of sight, out of mind. I think a lot of people stopped thinking about PageRank, but it's definitely still there. And the second question is, hasn't PageRank evolved so much that we can't really calculate it ourselves anymore? And the answer to that is, yeah, kind of, yeah. So there's been a lot of changes to PageRank over the years. It's no longer just dumbly distributed across links on a page. There's now weighting given to whether a link is visible, how high in the page it is, how related it is to the content on the page, or how related the content on the page is to the page it's being linked to. So there's a whole bunch of more smarts behind PageRank that we don't know about anymore. But for our purposes, we don't need to be 100% accurate in our calculation of it. We're using it as a composite measure of the other factors that we know are important. We've definitely found that traditional PageRank is still a good measure of how well a page will perform or how important Google thinks it is as well. So with multiple tests we've done in the past, we've tried to correlate the traditional PageRank with the crawl rate of Googlebot on a page. We think that crawl rate is a pretty good kind of proxy measure of whether Google thinks a page is important. And we always find that there's a statistically significant positive linear correlation with crawl rate. So basically what that means is that the PageRank we calculate correlates with how important Google thinks a page is. So it is still a valuable metric for us to be using in those ways. So I want to talk a bit about the tools and techniques we use to analyze sites. And I wanted to give a case study of the work that we've done. But unfortunately, the clients we work with, obviously their data is confidential. So I wanted to tell you about my new $1 million idea, which is llamastohome.com. So I know that it's a problem for a lot of people not being able to get a llama delivered to their house whenever they need it. So I came up with Llamas to Home. And I will show that right now. It's a real site to the extent that it's a site that exists on the internet. And you know, it looks like it was designed by a developer. So all it is some links to some different pages. So on my index page, I have links to my top countries, which are the US, Australia, the UK, Canada, and Japan. Some links to my top cities within those countries, and some top routes. So routes are following the idea that maybe I want a llama from a unique place. If I'm living in Atlanta, maybe I want a llama from Fort Worth. So on my index page, I've optimized to link to my top pages. If I go into countries, then I have some cross-links to the cities within that country, the top cities, some other countries that are geographically close by, and the top routes for llama delivery within this country. I've also included a cross-linking module that just randomly links across the site, kind of following a popular idea about cross-linking that every page on the site should be within about 3 clicks of the homepage. And whether or not that's true, I don't know, but well, I don't think it is, but I'll talk about that later. So from the country pages, I can link into cities. So I can look at the llamas in New York. Again, more cross-linking to cities. I have other nearby cities. I have filter pages. So perhaps I don't just want a llama in New York City. Perhaps I want a grey llama in New York City. So I can see all of the listings for grey llamas in New York City. And again, I have some cross-linking to other cities. I have linking to my other filter pages in New York. And I have my cross-links across the entire site. Within the route pages themselves, I have links to a whole lot of other route pages. So routes that go from the current city I'm in and routes that go to the city that I might want to be delivered to. And just in my main navigation, I have a full list of countries and a full list of cities. So that's a pretty good breakdown of the internal linking structure of my my $1 million enterprise. And this is a pretty common kind of linking structure we see, where it's hierarchical with some index page linking to the most important pages. So I want to talk about Llamas to Home's business model. So we have 5 countries that drive most of the profit to it. So the US, Canada, Australia, the UK, and Japan. And if I look at my search traffic to the site, I can see that most of my organic search traffic is coming into the city pages. So people are searching for llamas in Melbourne rather than llamas in Australia, or maybe local search is doing such a good job of picking up where I am that when I search for llamas near me, it's showing me llamas in Melbourne. So we want to take that on and break down the cross-linking structure to see if it's optimal, to see if the linking structure is matching up with our business needs. So the first thing we want to do when we do that is to attach some dimensions to our entities so we can write the reports that we need to visualize the state of the site. So because we're talking about crawling, there's really only 2 entities we need to care about. Those are pages and links. So for Llamas to Home, I want to attach 2 groups to my pages. So country, I want to know which country a page belongs to. And I want to attach page type. So I want to know if it's a city page, if it's a route page, if it's a llama filter page. And for my links, the only thing I really care about is the link module that they belong to. So if this is a link that's coming from the routes module, or if it's on the cross-linking. I'll say at this point that pretty early on in our project, we built our own crawler, which might seem like reinventing the wheel a little bit, because there are some really great tools out there for analyzing huge sites already. So we have a preference for Bodify when we're using a pre-existing tool. But there are a few reasons that we wanted to develop our own tool. So part of it was that we wanted to be able to join into external data sets on the fly. So an example of that would be if I was trying to geocode a location to, well, a page to the country level. In my URLs, I have an ID for the city, but otherwise no identifying information about what city it is and which country it belongs to. So being able to join dimensions from external data sets into our crawl data on the fly means that while we're crawling, we can join to a CSV or join to a database that has a lookup table of the city IDs and the countries they belong to, and we can get some really rich data into mixed in with our crawl data as the crawl is running. Having our own crawler also gives us easy access to all of the data. So Obviously for big sites, so I'm talking like tens of millions of pages and billions of links, the data volume is huge, and that's in the terabytes. So it becomes really difficult to get your data out of a pre-made crawler if you want to do more advanced reporting than just the pre-canned reports that you're given. So that's been an ongoing issue we've had. So having our own crawler that stores to a database that's locally available to us solves that problem. We can get much more specialized about the dimensions we're adding and get data down to a really super granular level with our crawler. So for example, we can look at how much PageRank is distributed by individual links, which is pretty cool. And one of the main ones early on was that the price is right. So there's no additional cost to us or our clients in using our own crawler. So now I have my my dimensions set up. I have an idea of my business. I want to start, and I have my crawl done. So I want to start doing some analysis on the site. So the simplest question I can ask is probably which page types is our PageRank being distributed to? And I can pretty quickly see that even though the Llama cities are the most important page type on the site, the majority of my PageRank is going to the city-to-city route pages. So even though 50% of my search traffic comes to the city page and only about 5% comes to the city-to-city route, most of my PageRank is wasted on those city-to-city route pages. So there's obviously a question that follows that, which is why is that happening? As I said, with our crawler, we can join, or we can figure out how much PageRank in individual link flows. And using that, we can say things like which pages are linking heavily and flowing PageRank to the city-to-city route pages and write reports on that. So we can look at our data and see that over 45% of the site's total PageRank, so a huge amount of the total PageRank, is being flowed from the city-to-city route pages to other city-to-city route pages. And the reason for that, when we look into it, is that because we have 500 cities and we're linking to combinations of all of them, so about 250,000 city-to-city route pages, we've created these cross-linking subnetworks, which just send links within themselves and hold PageRank down in those pages. So having discovered that, we can begin to put together actions to remedy the situation. So maybe a simple action I could take is just to cut down on the number of those city-to-city route pages. It seems like a simple idea that having too many pages on the site is going to be a drain on PageRank, but it's something that we come across a lot. So our first action in optimizing our site is just to not link to routes between cities of under 1 million people. So we've mapped out our first action. We can continue to do some more analysis. So now we want to look at our geographic distribution of PageRank. We've attached that geographic dimension to our data. And when I map that out, I can see that even though our main countries are the US and Australia and Japan and Canada and the UK, my map doesn't really match up with that. I'm flowing a lot of PageRank to China and the US and India. So my PageRank flow seems to match more closely to the population of countries than the amount of money they make me. I made a bit of a mistake with this map as well. It looks like Mongolia is getting a lot of PageRank. That's actually no data. So it's just a shame that's the same color as the US. So again, we can start to look further into our data to diagnose what the problem is. The first question we might ask is which link modules are sending all of those links to China? And then so we can get the links to China and group them together into the modules that they belong to. And we can see that the major culprits for linking to China are our from route and to route modules again, and our cross-linking module is sending over 15 million links to China. So based on that, we can again suggest some more actions. So we know that our cross-linking module is wasting links. So a simple action might just be to prioritize the top 5 markets when we generate cross-links. So based on the link data, we've done a really quick analysis and come up with 2 fairly quick actions. So the first action is not to link to routes in cities of under 1 million people. And the second is to prioritize our top 5 markets when we do cross-links. So I implemented those changes on the site and I recrawled, and we can see how that affects the site. So the distribution of links between countries begins to look better. The US suddenly pops out like crazy. You can see that Australia and the UK and Canada and Japan are a little bit less blue and a little bit more grey. We are still losing a bit of page rank to China, but I think that's just by weight of the number of cities there. And the distribution across page types starts to look a bit better too. It's not ideal. We're still losing a lot of page rank to our city-to-city route pages, but our city pages are starting to move up. So we're moving in the right direction. So we made the changes on the site and we recrawled the site and reanalyzed that. And now we've seen that we've improved, but we still have some problems. And not just that, we've started to introduce some bugs to the site. So, for example, on my cross-linking, I can now see that there are 2 links to llamas in Japan next to each other. And if we want to fix those, then with our current setup, that would mean that we'd have to make changes again, maybe try some different logic, maybe lower the number of well, maybe increase, the population of the pages we want to be able to link to from the route links, and then recrawl the site and redo the analysis. And that's quite time consuming, that's expensive in a few ways. So crawling a huge site is a long process. And it's pretty bandwidth heavy. So if you can imagine crawling a 10 million page site is at about 10 pages per second. It takes a bit over a week, or maybe a bit under a week. And it is going to put a huge load on the servers. It's just generally not something we want to be doing all the time. It's also time consuming and expensive in terms of the analysis required. So to solve that problem, we built something that we call a simulator to support rapid prototyping for link graphs. So the idea is that we can say, based on the last crawl we did, we want to see what happens to the site's link graph if we change the cross-linking module to only link to our top 5 countries. And then we can run that simulation. It might take a day to run, but it will spit out all of the metrics we're interested in reporting on at the end of that. So it'll spit out details like the amount of page rank flowing to pages in Australia and the difference between pre and post simulation. So the idea there is that we can begin to see how logic changes will affect the site without having to put them live. I'd love to give a demo of the simulator, but I think that we're going to run out of time if I do. So if anybody's interested, I'd love to give a demonstration. So just reach out to me or Paul and we can set it up. And my email is going to be at the end of the presentation. So doing simulations and things is kind of where we've gotten to with our manual analysis. So I want to talk a bit about our machine learning applications for internal linking optimization, which is, I think, the buzzy term that people are excited about. So after we've implemented our quick wins, things begin to get a bit harder. So it starts to become a lot harder to find the improvements that we can make across the site, even though we know that they're still in there. So we're beginning to use machine learning to identify pages which we think will benefit from receiving additional internal links. So as I've talked about, we know that internal page rank and click depth and other variables we've looked at so far are ranking signals, but they're just a few of many. I assume most of the people here are SEOs, so I'm not telling you anything you don't know, but there are just a huge number of other metrics to consider. So it's content quality and the number of external backlinks, and competitor data and external backlinks to competitors and the page's relevance to the keywords it's ranking for, and on it goes. And that's all a bit too much for people to analyze by hand. So our current project has to do with identifying pages that have ranking potential using a machine learning model. So basically, we've been training a machine learning model to predict how likely a page is to rank in Google's top 10 search results based on all of the factors we know about it, and then changing the amount of internal page rank that's flowing to it within the model to see how the output from the model changes. So to see if changing the internal page rank with all of the other factors considered is likely to change how a page ranks. So a really oversimplified way to think about that is that we're creating a formula that PageRank can be plugged into, and then we can test different page ranks into that formula to see how the output of the formula changes. So it could be ranking factor X times 4 plus ranking factor Y times 2 minus ranking factor 7 times internal page rank. And then we're kind of scaling the dial on that internal page rank up and down to see how the output of the function changes. An interesting side problem that comes along with that is a resource allocation problem. So we know that we have a limited amount of page rank to distribute across all of those pages. And we want to maximize the distribution of that page rank to the pages that actually will see some benefit from that. So the pages that our model tells us are likely to, well, are more likely to rank if they get more page rank. So there's an analogy that I've used to explain that to people in the past, and that's giving money out for treats. So imagine we have 5 friends who would all like to buy some treats, and we have a spare $10, and we'd like to help them buy their treats with the $10. For some reason, though, they don't want to tell us how much money it will cost to buy their treats. So Paul wants a Jaffa cake, Cecilia wants a Snickers, Ben wants a croissant, Kirsty wants a Tim Tam, and Freddie wants an eclair, but none of them will tell us how much they cost. Luckily for us, though, we have eyes that we can use to determine whether or not our friends think that they're getting enough money to buy the treats. So if we give a friend enough money that they think that they can buy a treat, then they have a smile on their face. And if they don't think they have enough money, then they're sad and they frown. So in the real world, our machine learning model is kind of acting as our eyes in this scenario. It's telling us whether a page is getting enough page rank to rank, or whether, based on what we've seen in the past, the page has enough page rank to rank. So now we need to find a method to distribute the money in a way that results in as many people as possible receiving their treats. So it turns out this is a pretty complex problem. If we take $1 from Ben and Paul and give those $2 to Cecilia, we might be just reducing the number of friends that can buy their treats. So maybe Paul and Ben really needed that $1, but the extra $2 won't bring Cecilia to the point where she can afford her treat. So we're following a path that will lead us to a worse result. But it's a problem where following the same path over and over doesn't necessarily improve the result of the output. It's a nonlinear optimization problem, which means that all of the different kind of spaces that the problem can be in are not, you can't follow just one path to get to the right outcome. And that problem becomes infinitely more complex when we try to scale that out to the millions of pages we want to optimize PageRank for. So we've been finding really great success solving that problem with an approach called genetic algorithms. So genetic algorithms are a class of algorithm that are really good for nonlinear optimization problems like this. They're based on genetic evolution. So finding a good genetic representation of the problem space that we're in, which is how much money we're giving to each person, and kind of or finding multiple genetic representations of how much money we're giving to people, and then like iteratively improving and combining those potential solutions to move towards finding an optimal. So just as an example of that, I built a little interface to our genetic algorithm, and I can run that to model the exact problem that we were just talking about. So I have $10 to distribute, and 5 friends. I've listed them here as children because I've done that in demos in the past. And we can run the algorithm. And for 5 children, it's not that interesting. It really quickly finds a kind of almost optimal solution to that every time. So the values over here, the distributions to each entity and whether or not they receive enough to get their candy. It becomes a little bit more interesting if I set this to be higher and set it to run for longer. So the generations kind of tell us how long the algorithm will run for, and the population size is how many different combinations of distributions we'll test within each generation. When I set that to 500, suddenly it becomes a lot more interesting to watch. So we can see that that we're starting off only distributing enough money for about 50% or a bit over 50% of our friends to buy candy. And pretty quickly, we start to move towards an optimum that's about 88%. If I let this run for longer, it'll keep getting a bit better, but it's mostly plateaued by this point. The main improvements within the first few thousand generations. So yeah, we're seeing some really promising results from using that method to optimize an entire site. And it's scalable across thousands and millions of pages. We're also starting just to dip our toe into using ML to solve some other problems for optimized cross-linking. So grouping URLs by page type is an ongoing problem we've had since we started working on internal linking projects. So that's the categorization of pages by type I talked about when I talked about how we want to add dimensions to our data. Usually we write regular expressions to match to URLs, and it's generally pretty easy and it works pretty well, but it's also pretty tedious and time consuming. So we've worked with clients who might have 70 different page types on their site, and some of the patterns in the URLs are pretty similar. So we can end up with some ambiguity there, and it's just time consuming. It's annoying. It makes life miserable. So we've done some work with teaching classifiers to identify page types. So basically saying, hey, here's a training data set. Here are some URLs. I know that this URL is this type of page. I know this URL is this type of page. And then letting the classifier do the categorization for us. And it works really well, which is exciting. We're also beginning to step into identifying URLs to link to, which are more relevant to the page we're currently on. So as I said at the start as well, we know that more PageRank is flowed through links that are relevant to the current page. So we're trying a couple of different things in that space. So linking to pages that have kind of similar attributes to the page we're currently on, so based on geographical attributes, or pages that, based on semantic analysis, have content that's similar to the page that we're currently on. So that's a pretty exciting project too. And just finally, I wanted to say that all of that sounds super theoretical, but we know that internal linking optimization really, really works. It's kind of a simple strategy to begin with and then gets more complicated. We know it works because we consistently see it perform well in analyses of the ranking signals by some of the big aggregators. So for example, Moz does semi-annual analyses of what the big ranking signals are, and they still say that internal page rank, or maybe not internal page rank, but internal links are an important factor. John Mueller, we know that we have to read between the lines a little bit when we read his statements, but it's not hard to find statements by him that explicitly state that internal linking is a big factor for Google. And we've seen it for ourselves. So on some of the sites that we've worked on, we've seen some pretty statistically significant uplifts of the number of sessions on those sites. So after applying causal impact on the site and on sessions, after applying the cross-linking changes, we've seen uplifts in sessions in the range of 10 to 20%. And that's generated millions of dollars in extra revenue for those pages, or for those sites, sorry. So that's it for the presentation. So thank you for listening. Again, I'd love to hear from you if you want to see my simulator. So that's my email address, and feel free to get in touch with me or Paul. And that's it.
Thank you, James. That was super insightful. So I think we're going to open it up to questions now. If anyone has any questions, the process for doing that is via the chat box. So I'll give you a moment to formulate questions. Hopefully not questions like what's a link. We don't want that. We don't want that question. Okay, doesn't look like we've got any questions coming through right now. So I've got one, which is really around kind of you covered a huge amount of work there that's probably taken you 3 to 4 years on a to get to where you are today and present that. Is there any particular area that caused you the biggest amount of pain?
Yeah, I'd say the scale of the data that we're working with has been the biggest issue we've had. So again, working with potentially 1 billion rows of data for links, and sometimes with multiple points of sale for a particular, so multiple sites for a particular client, we've ended up with data sets kind of in the range of maybe 8 billion rows. So we've had to try to figure out how to structure that data in a way that's queryable in times that don't make us tear our hair out. A lot of time's been spent working on how to make the data actually usable within a tool.
Excellent. So Bilal has asked, which tools can we use to do a similar analysis for a smaller website? For instance, I used Gephi for graph analysis.
So I think that some of the commercial crawlers are fine for that. So like just using Botify is pretty reasonable for that. I guess it depends if you want to be joining in external data, which again is why we needed to build our own processes around that. But yeah, we do have a pretty strong affinity for using Botify for cases where we don't need to do kind of huge joins to huge data sets.
Yeah. Glenn, thank you for the question. It is, what's the minimum size for this kind of analysis, and how much does a llama cost?
Depends on where the llama's from. Look, I wouldn't say there's necessarily a minimum size. Probably for a page with a site with 200 pages, it's a waste of time. Maybe when we're moving into the tens of thousands of pages, it starts to become important. Then you start to see some proper wastage. Yeah, our experience with seeing benefits does come from bigger sites. So so sites that are in the millions of pages and which probably have a lot of wastage. But yeah, that's a long way to say probably a site over 10,000 pages, it's worth doing it for.
Yeah. That's pretty much the number that we use when we're talking to people, is around, yeah, that kind of 10,000 pages and above. And yeah, publisher sites, classified, large e-commerce websites. This is made for that area. We've also got a question from from Ho, Waylon. Sorry, it moved. So the question is, just wondering if internal linking optimization is important when you are launching a new website, or is it optimization we should do down the line?
Yeah, I'd say it's important when you're launching the site. The I guess drawback of that is that you don't get to see how much it improves things because you don't have the state of the site pre-optimization to compare to. But maybe that's a good thing. Means that you're not losing business in the meantime. But yes, I would say it's important. It's not something that kind of kicks in later, especially as you're building up kind of backlinks to the site. It's more important not to be spreading your authority too thinly.
Cool. I think that is all the questions that we've got. So, oh, there's one more. So how do you implement the recommended changes that have been identified if there's thousands of updates identified?
So, good question. So usually we wouldn't think about updates kind of at a small level. We'd think about big logic changes we could make across the entire site. So we might not say, hey, we think that on this page, unless it's a particularly important page, so like an index page, we wouldn't say, hey, we think that you should link to these pages on this one page instead of these pages. We'd say maybe, hey, on your Llama City page, you've got a bug in your module that links to the routes, and expect that a change to that will roll across all of the pages of that type. If there's a whole lot of different changes we find, if there's like it's a bit of a cluster, we'll definitely sit down and prioritize the quicker wins and the things that are easier for the dev team to implement and that we think will be most impactful. Again, the simulator is good for telling us what those changes will be. So we can say, hey, this change that we recommend making on the city page will give you more benefit than this change we recommend making on the routes page. So.
Excellent, thank you, James. Cool, so it looks like that is all of the questions, and we're just over time, so that's by 2 minutes, so that's perfect. So once again, James, thank you for putting together that presentation. As I'm sure everyone will agree here, it's just a super interesting topic. And I think I personally, just from going to a lot of conferences and reading a lot on SEO, not a lot of people talk about internal links. So it's really good to get that overview of how they can be used in a really effective way and at scale. So yeah, thanks for sharing those insights. If anyone's got any questions on this, feel free to send me a message. Either you've got my email address, paul@inmarketingwetrust.com.au, or you can get me direct through the meetup. And two final notes before we finish up. The first is, don't forget, I am sending out that email via Meetup. So please do take the time to give us your feedback. Also give us that review. I'm asking for a lot of stuff here. And also don't forget to show up for the talk on the, or sign up for the talk on the 2nd of September at 6 p.m. Australia time by Sam. That's going to be a great session on data-driven creative. So thank you all, and hope you all have a good rest of the evening. See you again soon. Bye.